All right, you guys, I am going to do my best to help you understand box and whisker plots, which is kind of a good majority of this little video, and understanding mean, median, and mode. So we already did mean, median, and mode. Okay, as far as the definition, you didn't really have to practice a whole lot. Mode is what the highest frequency, median is in the middle, and mean is what we typically call the average, which is add them all together and divide by the number. All right, so here are the number of calls received during 21 randomly chosen 15-minute time intervals at a customer support service. All right, so you can see that there were 2 calls between this first 5. Well, I mean, sorry, there were 2. Wait, hello. Oh, there were 2 calls. There were 2 calls underneath 5, from 5 to 10, like 5 to 10 calls. There were 4. Okay, there were 9 from 10 to 15, and this is, so you can see that in the middle, these 10 to 15 was the highest number of calls. Okay, in a 15-minute interval, that was the highest frequency. All right, so for these data, which measures of central tendency, these are the measures of central tendency, take more than one value. Choose all that apply. So you literally have to figure out the mean, median, and mode here. Okay, it's just what you have to do. So for the mean, you need to add up all these numbers and then divide by 21, because that's how many there are. All right, so you literally just get out your calculator. I don't do this by hand at all. Okay, I mean, you can, but I don't. 1 plus 4 plus 6 plus 6 plus 9 plus 9 plus 11 plus 11 plus 11 plus 12 plus 13 plus 13 plus 14 plus 14 plus 14 plus 17 plus 17 plus 18 plus 19 plus 22 plus 24. My method of keeping myself straight is reading it out loud because it's hard to do it otherwise. Okay, I divided that by 21 and I got 12.6. So my mean I got was 12.6. Okay, the median means it's the middle and you must order it from least to greatest to get there. All right, so if there's 21, okay, I do this. I don't know about you guys, but I literally do like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then from the other side, let's try 1. Hello. No, my dear. Let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, good. So right in the middle is 13. Okay. So 13 is the median, right in the middle. All right, and the mode. So we're looking for the highest frequency. We have 3 11s right here, and you have 3 14s. Okay, so the mode is going to be 11 and 14. Okay, so which of these data, did you guys know that a single piece of data is data and then I think multiple pieces of data are called data. One is plural and one is singular. Okay, for these data, which measures of central tendency take more than one value? Mode, that's going to be it. It has one value. Suppose that the measurement 24, the largest measurement in the data, okay, were replaced by a 46. So let's pretend it was replaced by 46. Which measures of central tendency would be affected by that change? Okay, so which is going to be affected? Is the mode going to be affected? And the answer is no, it's still going to be 11 and 14. Is the median? No, because it's still going to be 13, it's in the middle. However, the mean would be changed because we're going to add more. So when we divide, it's going to be slightly higher than 12.6. Maybe it'll be 13. point something, or maybe it'll be 14 point something. I don't know. Suppose that starting with the original data set, the largest measurement were removed. Which measurements of central tendency would be changed from those of the original data set? Choose all that apply. Okay, so now you're doing a suppose that. Okay, so they're saying, whoa, let's not do that. That was crazy. I didn't know I was going to do that. Oh, I know what I need to do. Let me lock this down. Lock all. Okay, now I can erase. That was weird. Okay. Hello. Oh, I locked even my writing. Oh, forget it. Okay, so in other words, if we took this guy away, like there is no 24, that's what this is saying. Suppose that starting with the original data set, the largest measurement were removed. What's going to be changed? Well, you can see that the mode isn't going to change because it's going to be the same. So that's not going to change. But the median is going to now be, where is the median? We got to go one more over here. So in other words, the median might change because we are now, let's see, if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm going to be there, and this is 9. So it's going to be between these two because now we have an even number, right? So it's 20. So in other words, the median is going to change to 12.5. We'd have to take the average. So that's going to change. And also the mean is going to change because anytime we change a value, we remove or replace a value or add a value, the mean is going to change. So I would choose both the mean and the median. Which of the following best describes the distribution of the original data? Is it negatively skewed, positively skewed, or roughly symmetrical? And the answer is roughly symmetrical. And what they're looking for there, negatively skewed means that you have more on the negative side. Like if this is the middle, if this is your median, you have more values, more occurrences on the negative side. Positively skewed means that if that's the median, you have more on the right-hand side. Okay, greater number. And then symmetrical means like this. Woo, bell curve. Okay, that's symmetrical. I could just draw a thing like a symmetry down the middle of this, and then you got it, okay? Next. Boom. All right. What just happened to everything? You guys, this is really strange. I know what happened. I was like, it went away again. Okay, so it says, it seems that, well, actually, let's read the title, Approximating the Mean of a Data Set. Okay, so we are approximating, given a histogram. So it seems these days that college graduates who are employed full-time work more than 40-hour weeks. In a survey for a recent year, there were 77 respondents, 77 total, who were college graduates employed full-time. The reporting number of hours each worked per week is summarized in the following histogram, which was displayed in a government publication. Okay, so we can look at this number of hours work per week. So we have 3 people working 51 to 55-hour weeks. Okay, and you guys can do the math on that one. If you're working a 55-hour weekday, that is averaging 8 hours a day, 7 days a week. That's crazy. All right, 9 people were working from a 46 to 50 hour. 13 people were working 41 to 45, 19, 36 to 40, and 25, 31 to 35, and 8 people from 26 to 30, okay? So based on the histogram, using the midpoint of each data class, estimate the mean number of hours worked per week by these respondents. Carry your intermediate computations to at least 4 decimal places and round your answer to 1 decimal place. So you are going to be taking, okay, for each data class, estimate the mean number of hours worked. Okay, so if we look at 8 people, we're looking at between here. So it'd be 28 times 8. Okay, and then we're looking at the middle of here, which is 33. Okay, so you would have 28 times 8 plus 33 times 25. I'm sorry, I did that backwards, right? Yeah. Okay, but it doesn't matter. 38 would be the middle here, plus 19 times 38 plus 13 times 43, I'm going to say, because 43 is in the middle. That's the midpoint. The midpoint between 46 and 50 is 48, and there's 9 of them. 9 times 48, sorry, 9 times 48. I did that one weird, but it still means the same thing. And then plus 3 times 53. Okay? All right, all divided by 77. The midpoint, estimate the mean number of hours worked per week by these responses. Okay. It says carry your intermediate computation to 4 decimal places. That's interesting. So what I did was I took the midpoint and I'm multiplying it by 8 people, right? And then I'm taking that midpoint and that and that and that and that. Okay. Part of me thinks that they want you to do the midpoint, which is like 28 hours. I can't think of any other way that they'd want you to do this. Okay, and put it in a calculator. Okay, I'm going to double check with Alex just because. Okay, I just double checked, and because I was like, why would we carry it to 4 decimal places? That makes no sense. Round to 1 decimal place, which is the 10th. This is totally right. You take the midpoint, you multiply by the numbers, and then you add them all together and divide by 77. It's a calculator problem from here out. So that is how you do it. You look for the middle of this number. This is where I grabbed all those, you guys. 28 times 8, 33 times 25, right? 38 times 19. Get it? It's the midpoint, even though I drew this terribly. Okay. Next, I don't want to waste your time. You guys can do the calculations when you actually do your problems, right? So Gina asked 15 students how many courses they have taken so far at our college. Here's a list of answers. Okay, what percentage of these students have taken fewer than 6 courses? Okay, so again, percentage, piece out of the whole, okay? And then if you want percent, remember it's equal to something over 100, or you could just go multiplied piece over the whole times 100 will give you percentage. All right, so we want to know have taken fewer than 6 courses, okay? There is one person right here. There is one person here, and there's one person here. We don't do the 6 because it says fewer than, not fewer than or equal to, or at least. It doesn't say at most 6 courses or whatever. So we only want those that are at least. So only 3 people out of 15. So you'd go 3 is the piece, 15 is the whole, multiply it by 100 to get percentage. Okay, and that will give you a percent. Next. Right. If you can't tell, you guys, I think you can tell by now that this is not always my favorite thing to do. All right, the following ages are the ages of 14 physics teacher in the school district. Only these guys would be in a higher realm, higher, whatever it's called, danger zone for COVID. All right, so notice that the ages are ordered from least to greatest. Give the 5-number summary and the interquartile range for the data set. So this is new words for you, interquartile and 5-number. Basically, what you're going to do is you're going to be looking at this data and you're going to be dividing it into quartiles or fourths. Okay, and what we're looking for basically in these fourths, this is what we're kind of looking at. This is the upper 1/4. This is the lower 1/4. Okay, and this would be the middle, you know, like next to the 1/4. So this is 1/4 and 1/4. In the middle here, okay, would be the median? Median or mean? I'm thinking it's the median. I think it's the median because we want to know where yes, it's the median because we're dividing these into their fourths, not their values. Mean always has to do with value. Median is in the middle. So what we want to do is take a look here. Okay, first of all, what's the minimum value? 26. That's going to be the lowest. Okay, the maximum is going to be the 56. Okay, the lower quartile, median, and upper, oh, they even tell you it's right here. Okay, median. Let's find the median first. That's the easiest. So there are 14, which means it's an even number. So if I go over 6, you guys, I actually don't do this like this myself. I kid you not. I use my finger. So I went 1, 2, 3, 4, 5, 6. And here I went 1, 2, 3, 4, 5, 6. So there is no middle number because it's even. So these two are the middle numbers. So you add them together and divide by 2, and you're going to get 41.5. So that is your median, 41.5. Okay, so then from here, let's just assume the median's right here. Okay, we are going to need to do the lower quartile. So we got to divide this into fourths, okay? So we have 1, 2, 3, 4, 5, 6, 7. We're going to go down. Look at that, y'all. I'm going to delete that because that's nice. Get rid of that piece of crap. Okay. All right, here we go. So what we're going to do is we are going to find the middle from here to here. And we need to find the middle from here to here. So there's 1, 2, 3, 4, 5, 6, 7. So it's going to be the one right in the middle. Okay. So 33 is the lower quartile. Okay, marker. And the upper quartile is going to be from 43 here. 1, 2, 3. Okay, right here. I actually, when I do this, you guys, I kid you not, I use my fingers and I start at opposite ends and then I just move my fingers progressively towards the inside. Okay, so 45. Interquartile range, that means from the lowest to the highest. So it's going to be 56 minus 26, which is 30. In other words, what they're saying is from the lowest to the highest, there's only 30 points. Okay. Sometimes in my tests, I might have a kid get 100 and I might have a kid get a 5. That has a range of 95. Okay. All right. Next. Okay. Here are the scores of 17 students on a history test. We got to construct a box and whisker plot. I got to tell you, for some reason, you guys, I have a serious attitude about box and whisker plots. And I think it's because I never learned it in school. I've never seen it used except once in real life on an GRE, which you don't even know what that is, some test score that they were doing. I've never seen it used, but you will be tested on this like it's the most important thing. And it drives me crazy. All right. So what you do for a box and whisker data point, okay, is you're going to, basically the data exists here. You're going to be putting this box. In the middle is going to be basically what we constructed, the median, and then you're going to construct the whiskers, which is, okay, the average. Okay, so the box and whisker plot is going to be, let me make sure. I want to say it's the mean, not the median. Okay, yes, it's the median. I keep doubting myself for whatever reason. Yeah, this is again the median of this half, and this is the median of this half. Basically, what we just did in the problem before. So if we're looking at this data set, okay, we're going to be finding the median. So there are 17, which means it's going to be kind of nice. It's right smack in the middle. I'm going to go 3, 4, 5, 6, 7, 8, maybe. Let's see. 1, 2, 3, 8. Okay. Right there, that's the median. So you're going to put the 74 here, okay, right in the middle, okay? 74 is in the middle of the box. This is a 74, okay? Now the median goes in the middle and the two sides are going to be composed of, and I guess I really shouldn't actually draw them yet, you guys, because we don't know where they're at right now. Okay, so let's just construct it. Ready? So let's do the 5 points first. Okay, so the median, I'm going to grab the median first, even though it's in the middle, okay, is 74. Then we want to get the lower quartile, okay, marker. So that's, again, the median between of these guys, okay? So we're going to go from here in. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, including the median, of course, okay? So 1, 2, 3, 4. I believe that's it right there, 66. Yeah, 66. And in here, it's going to be, I think this is the middle. All right. So 74 is the middle. Lower is at 66. Upper quartile is going to be at 82. So when you guys grab it, you're going to be able to grab your ALEKS things and you're going to be able to play with this. So if I'm looking at this and it's actually like a real graph, let me just erase this. Okay. So if I'm looking that the middle is 74, okay, and 66. So 66 is 8 this way. So let's say this is 4. There's 8. Let's say this is 66. Okay. And 74 to 82 is 8 as well. That was kind of lame, y'all. Shouldn't be even. It's more interesting when it's not even. Okay. So this is 82. Okay. Then that's going to be your box. And what it does is it shows you that the quartiles are pretty evenly spread out. Now, what are the whiskers? The whiskers go to the highest, 86, because that's 4 more that way, and the lowest. Where's the lowest? 59, which is 5.7 from 66. So that's 59. So the lowest, the highest, the median of this data, the median of the whole data, and the median of this data. And that's your box of whiskers. And what it shows you is how the data is distributed. That's what it does. If you get a box and whisker like this, where the median is right in the middle, okay, I mean, you get median and it's skewed right, okay, it just tells you that there were more people that got like these, or not people, I guess, more scores on the highest or more data on this side than the other side. Yeah, okay. Not more data, I don't know how to say it. Higher scores is what you want to say, higher numbers. All right, take a look. Okay, so now we're looking at box and whisker plots. So take a look. The idea is this is skewed a little to the left and this is pretty balanced. Do you see the range here? Look, this low and to this high is much greater than this low and high. And what we're comparing is the noon temperature in two cities. I believe this is more like Albuquerque. This is more like New York, where you're in a desert, you have low and high temperatures. So it says, in which city rather, had noon temperatures, because this is a noon temperature graph, with a larger interquartile range. And that's going to be this one, because it's way there. Okay, so it's going to be A. Which city had a smaller range of noon temperatures? Well, that would be B. That's kind of stupid. Okay. Yeah, unless I'm wrong about the interquartile range, you guys can let me know. Which city had a larger median noon temperature? I don't like the word larger. I like the word higher, but it would be B, because B's is higher. It's like it's 66, whereas the median here is at 64. Okay, which city had the highest noon temperature? This city did. That's the highest. Okay, so it's city A. All right. Next. That's how you read a box and whisker plot. Okay. The noon temperatures, okay. sorry, I recorded that and I was going to put the directions over there and I forgot to. So whatever. Okay, last one on this slide is Introduction to the Counting Principle. And counting principle is how many combinations can you put? I don't want to even use the word combination because combination and permutation are going to have very special meanings in a little bit for you guys. So basically, we're looking at how we put together data, okay, or things. So the Lopez family is selecting a furniture set. It has a bed and a dresser. There are 3 beds and 3 dressers to choose from. How many different furniture sets could they select? So you kind of consider that there are 3 beds. So bed 1, bed 2, bed 3. Well, if you choose bed 1, you could choose 3 dressers. You could choose dresser 1, dresser 2, dresser 3. Or if you chose bed 2, you could pick dresser 1, dresser 2, dresser 3. Or bed 3, dresser 1, dresser 2, dresser 3. So altogether, you end up with 9 combinations, okay? So 9 choices. So how many sets? 9 different sets they could choose from. And what this is you had 3 choices. I can't do this. Let's try 3 choices and 3 choices. I could have arrived at 9 by doing 3 times 3 equals 9. Okay, so in many ways, like you'll see this a lot with, you go to a hamburger shop, okay? Or they do it with colors or letters or something like that, okay? The counting principle is basically you can multiply the choices in each choice, the number of choices in each choice. For example, let's say you go to a hot dog stand, okay? And they sell hot dogs, hamburgers. Can they spell hamburger? Maybe. Hamburger, and let's say they say a fish sandwich, okay? So they have 3 choices. And then let's say they have 5 choices of beverages. Of beverages. Well, that means that you could get a hot dog and you could get 1, 2, 3, 4, 5 choices. Okay. And then let's say you got to choose between fries and onion rings. So there was 2 choices there. Okay. So let's say you got a hot dog and a Coke. Let's say that was one of the beverage choices. Well, you could also get fries or onion rings. So in other words, the choices just keep like expanding as you do this. You have 5 choices for a drink. And then each of these have 2 choices for fries or for onion rings, right? So at the end, rather than draw all these like silly little like rays, you can go, okay, I got 3 choices for a main dish. I have 5 choices for beverages, and I have 2 choices for sides. So altogether, I have a possibility of choosing 30 different ways to do that. 30 different ways to order food. Okay? And 30 different combos, basically. All right, and that's the beginning. And it kind of gives you the idea of combinations, where it doesn't matter what order you put them in. Like, in other words, I could have chosen my beverage first, and then I could have chosen my main dish, and then my side. But either way, it's still going to be 30. The next video is going to talk about permutation, where order matters. And that's a whole different thing. Okay. Combination. By the way, I think I'm going to get into this in the next video too. This would be represented by, I have to look at it. Never mind. We'll hit that in the next video.